Hi everyone, welcome back to Fat Cat Maths. Today we're going to be looking at simultaneous equations. Quite often in algebra, we will be given a question like this, and we have to try and figure out what x is. These kinds of questions only have one solution. X can only equal 6. But what about when we're given something like this? There isn't only one solution anymore. X could equal 4 while y equals 1, x could equal 2 while y equals 3. The list would keep going on. So that's why we need to be given two equations when there are two unknowns. If we're given two equations, or simultaneous equations, where x and y equal the same thing, we can figure out what x and y actually are. With simultaneous equations like these, x has to equal 4 while y equals 1, because otherwise both equations wouldn't make sense. So let's look at this example and go over the steps. The first thing we need to do is make the number in front of either the x or the y the same. So here, we don't have the same number in front of the y's, but we do have the same number in front of the x, so we don't need to do anything here. The next thing you want to do is add or subtract your two equations. If I added these two equations together, I would get 4 lots of y and 4 lots of x. That doesn't help me. But if I took them away from each other, I would get a minus 2y plus nothing equals minus 10. This is the goal. We want to get rid of either the x or the y and be left with only one unknown. Once we've done that, we can solve for our y. If minus 2y equals a minus 10, then we divide both sides by 2, and we know that minus y is minus 5. If everything is a minus, we can just times everything by minus 1. So essentially, we're just getting rid of the minuses for everything in our equation. Then we pick one of our original equations. I'm going to pick the easiest one, but it doesn't really matter which one you choose. If I choose the y plus 2x equals 9, and I replace the y with what we now know to be 5, I now have an equation that only has one unknown in it, so I can solve it. I can rearrange that to get 2x equals 9 minus 5. If 2x equals 4, then that means that 1x equals 2, and I've now solved both x and y using simultaneous equations. Let's try with another example. Hopefully you've spotted that this looks a bit different to the last one because instead of both the x and the y on the same side, we only have a y on one side of the equals. So to set ourselves up, we need to have the 2x on the other side. To do that, we just change it to a minus. So now I have minus 2x plus y equals 1 and x plus 2y equals 17. I want the same number in front of the x's or the same number in front of the y's. If I times the whole of the top equation by 2, then I will get the same number in front of my y's. Now I'm going to add or subtract the equations. I'm going to take these two equations away from each other, because 2y take away 2y is nothing, and that's the goal. A minus 4x take away an x is a minus 5x, and a 2 take away a 17 is minus 15. So now I can solve my equation. Remember, if everything is a minus, we can just change everything to a positive. If 5 lots of x are 15, then 1 lot of x will be 3. Now I'm going to go back to my original equations and replace x with a 3. It doesn't matter which equation you choose, I'm just going to choose the top one. If y equals 2x plus 1, and we know that x equals 3, we can solve it. If y equals 6 plus 1, then y equals 7, and we have solved our simultaneous equations. Pause the video here and see if you can solve this one on your own. We've got different letters here, which you might get in the exam too. Don't get thrown by them, it's exactly the same as having a 3x plus a 2y equals 1. So the rules are the same. We want to make the number in front of, this time the a or the b, the same. We don't have the same number in front of the a, but we do have the same number in front of the b. Next, I'm going to either add or subtract my equations. I'm going to subtract them because that's the only way to get less than before. So 3a take away a is a 2a, 2b take away 2b is nothing, and 1 take away 5 is minus 4. Now I'm going to solve my equation. 2a equals minus 4, which means that 1a equals a minus 2. Next, I'm going to choose one of my original equations and replace the a with what we now know to be minus 2. So if a plus 2b equals 5, a equals minus 2, so minus 2 plus 2b equals 5. We can move that minus 2 onto the right-hand side by changing the sign in front of it to a positive. So now we have a 2b equals 5 plus 2. That means that 2b equals 7, and if 2b equals 7, then 1b will equal 3.5. So now let's try and do a question without the rules written in front of us and where there is a minus involved. So just as before, we want to make either the number in front of the y or the x the same. If I times the bottom equation by 4, then we could get a 4 in front of both of our x's. Because we've got a minus here, things get a little bit trickier when we think about whether we have to add or subtract the equations. If I do minus 4x take away a positive 4x, I'm going to the left-hand side of my number line. So I'm going to end up with a minus 8x. That doesn't help me because we want to try and get rid of either the y or the x. So instead, I am going to add these two equations together. 5y add 4y is 9y, a negative 4x add a positive 4x is 0, and an 8 add a 28 is 36. So if 9y equals 36, then we divide both sides by 9, which means that y equals 4. So now I'm going to take one of my equations and replace the y with a 4, because we've just figured out what that is. If y plus x equals 7, then 4 plus x equals 7. I can put that 4 on the right-hand side by changing its sign. So now x equals 7 minus 4. Therefore, x equals 3. So that is the end of the video. Thanks so much. Please hit that subscribe button and I will see you next week.